Now that you have an overall view of how a test works, what a p-value and a test statistic are, let's look at our first two objectives where we're going to state and check the conditions for a significance test. And we are going to calculate a test statistic and a p-value for a test about a population proportion. So here's our first example. According to the US Census Bureau, the proportion of students in high school who have part-time jobs is 0.25. An administrator at a local high school suspects that the proportion of students at her school who have part-time jobs is less than the national figure. She would like to carry out a test at the significance level of 0.05. So her null hypothesis is that it's equal to 25%. Remember, you assume it is true until you provide evidence that it's not. So the alternative is that she thinks it's less, and P is the true proportion of all students at the school who have part-time jobs. The administrator selects a random sample of 200 students from the school and finds that 39 of them have part-time jobs. So let's check if the conditions for performing a significance test are met. So first, was it a random sample? Yes, they said it wasn't a problem. 10% condition, it's safe to assume that 200 is less than 10% of all the students at, if it's a large high school. And then we have to check the large counts. So we have to say there were 39 successes and 200 minus 39 would be the number of failures. So it seems to me that all of these conditions would be met. They told us it was a random sample from 200 students from the school. So the first condition is met. 200 is less than 10% of all students at a large high school. So the 10% condition is met. Usually a large high school has over 2,000 students. The large counts condition, we have to assume the null is true. So that's why I do n times p naught. So the sample was 200, the null was 25%. So we'd expect 50 successes and we'd expect 150 failures. Both of these are greater than 10. So this tells us the sampling distribution will be approximately normal. I want you to notice we didn't use the sample of 39 successes when we're checking the large counts for a significance test. You're assuming that the null is true. Next question, explain why the sample results explain why the sample result gives some evidence for the alternative hypothesis. In the sample, 39 out of 200 had part-time jobs, which is less than 25%. So that's why at first it gives us some evidence for the alternative, which is that the proportion at the school are less than 25%. Again, the sample proportion of students at the school was less than the national average of 25. So it's suggesting evidence for the alternative, that it's less than 25. Here we'll calculate the standardized test statistic and the p-value. So first, I always want you to find the test statistic and use that to calculate the p-value. So the formula for the test statistic is the statistic minus the null divided by the standard deviation. Later on the notes, you'll see this formula, but the next step, and I want to show it to you right now, our statistic is p hat. The parameter or the null is p naught, and then the standard deviation of the statistic is the formula for the standard deviation, assuming the null is true. So later in the notes, you'll see this formula pop up again. I just want you to be familiar with what each of these mean. And so now we'll plug in, we'll calculate the z-score or the standardized test statistic for this problem. So we get a standardized test statistic of negative 1.80. So that means this sample statistic is 1.8 standard deviations below the mean, which isn't as rare as our previous problem. So we'll see, we'll get a larger p-value. The common error that students make is they want to use 19.5% when they're finding the standard deviation. But again, you have to assume the null is true. So that's why we're using 0.25 and 0.75 here. So now we can use this value, our test statistic, to calculate the p-value. just to give you a visual of what we're doing, we're taking our test statistic, our z-score, finding the area, the probability of it being negative 1.8 or more extreme. So that's why we have lower from negative infinity, upper to negative 1.8, and the mean and standard deviation are 0 and 1. So our p-value is 0.035. So with that p-value, well, I guess we don't have to find the test statistic like I said before, but I want you to. I want you to always find the test statistic and then use that to calculate the p-value. But we could have done from negative infinity to our sample with the standard deviation of plugging this in for our standard deviation, it'll give us the same p-value. But since you have to find the test statistic, I always want you to find the test statistic and use it. So what conclusion will we make? Well, all we do is we measure our p-value against the alpha level, which was 0.05. So in that case, our alpha, our p-value is smaller than our alpha level, so we're going to reject the null. Since our p-value of 0.0359 is less than our alpha level of 0.05, we reject the null. We have convincing evidence that the true proportion of all students at this large high school who have part-time jobs is less than 25%. So the way that we word this is really important. We have to make sure that we measure our p-value against our alpha level. We say we reject the null, and we need to say that we have convincing evidence, because you can't reject until you have that convincing evidence. And then lastly, make sure you're applying the context here. And the reason that we reject is because if the null is true, it's very, very unlikely that we only get a p-hat of 19.5%. It must mean that the null isn't true.